Hi everybody, this is the second recording. It covers exercise 3 from section 2.5. Again, we're finding the local extreme of a function, in this case x cubed minus 3x plus y cubed minus 3y. You'll notice that it's symmetric in x and y, so anything we say for x we'll be able to say for y in this problem. That'll make things go pretty quick here. So first we'll find the critical points, and to do that we're going to look for the gradient. And, well, it's the same as in the last problem, that the gradient in the x direction will be 3x squared minus 3. And since this is symmetric in x and y, it'll be 3y squared minus 3 in the y direction. So where will the gradient be 0? Well, we need 3x squared minus 3 to be 0 and 3y squared minus 3 to be 0 at the same time. In the last problem we saw the top equation means that x is plus or minus 1. So of course the bottom equation has to mean y is plus or minus 1. So we're going to get 4 critical points in total. We'll get one for when x is 1 and y is 1, x is 1 and y is negative 1, x is negative 1 and y is 1, and x is negative 1 and y is negative 1. Alright, so now we need to test these 4 critical points, and we'll use this second derivative test again. So this tells us again we're going to have to look at these second partial derivatives here. So in the x direction, we get 6x, like in the last problem. In the y direction, well, it's 6y, symmetric. And in the xy, well, when we just do it with respect to x, we only get x's. And so when we do that with respect to y, it'll be 0. Alright, so now we need to check all 4 of these points. But it actually works out pretty nicely. For both 1, 1 and negative 1, negative 1, you get 36. Of course, this doesn't matter at all, and well, what's happening when you put in 1 for x or for y, you're getting 6 out. And if you use negative 1 and negative 1, well, when you multiply them, the negatives go away. If you use the mixed ones, where you have one x or y which is negative and the other not, then they both are going to give you negative 36. Okay, so when d is positive, we have to check this fxx again. And, well, if x is 1, we'll get 6, which is positive, and we'll get a local min. And if x is negative 1, then we'll get negative 6, and so we'll have a local maximum. When d is negative, well, we immediately know we get a saddle point. So that's our answer. We get a local min at 1, 1, a local max at negative 1, negative 1, and 2 saddle points. To see the other exercises, you can click the links on this page.